All right, guys, this is going to be the video lesson for Chapter 11, Section 2, which is starting to get into surface and lateral area of prisms and cylinders. You'll see why prisms and cylinders are kind of related in a second. But a couple of keywords that you've got to get out of the way. First of all, what is a prism? A prism is any type of a shape, and I'll draw one here, that has these type of lateral faces. Let me see if I can get that one in the right direction. Easier said than done drawing this way, but there is a rectangular or perhaps square prism. They're always named by their bases. So the base is here. Okay. Lateral faces are these rectangles around the side. And some of this is a little bit of a review, but you always name these prisms by the base. Typically, the lateral faces turn into rectangles. Um, Cylinders are a little bit different, but we'll talk about that in a second. You've got two types of prisms. You can have a right prism, like this one would be, where you can see that it's at a right angle everywhere around. But you can also have what's called an oblique prism. If you've got a slanted type of shape from the base, then you would see an oblique prism. I'm not even sure if I'm going to be able to draw one easily here. Hopefully I can. But with this tool, it's going to be a little bit tougher. We'll see if I can get it. Now, because I'm turning it, I can't even do one without thinking about it further, because this one was about to turn into a right prism just on its edge. So either way, look at the book and you'll see an example of an oblique prism. Just notice that the height of an oblique prism occurs outside of the prism, similar to the height of a obtuse triangle. The height here is going to be the connection between the two bases. Okay. And then you'll have the perimeter of a base and also the area of a base, which will be part of our formulas. One way that you can figure out the area of a prism is to get the net of the prism. Remember that a net is basically a cutout drawing of it. So if you had a net of a rectangular prism, or excuse me, is this rectangular or square? Looks like it's rectangular. You would have something similar to what's in the book, like this, where you've got two rectangular bases and it kind of forms a T. Guess where the bases are in this net? Here's a base and here's a base. Everything else is the lateral faces. And so if you were given a net like this, you would just need to add up the area of every single part of the net. So the area of 1, 2, 3, 4, 5, 6 different rectangles will give you the overall area of this rectangular prism. I don't want to focus too much on nets because I think the nets are relatively easy. You can just do length times width, find all the areas of them, or if it's a triangular net, then use 1/2 base times height, or the others that we've learned. Instead, I want to focus on the lateral and surface area calculations and formulas. The lateral area of a prism, and this is something that I would normally have up on the board, is going to be a key thing for your test. I would even create a little cheat sheet of all these calculations because we're going to do both lateral area and surface area of all of these. Let me even write that a little bit better. So we're talking about lateral area. Lateral area is the area around the prism, not including the bases. So the lateral area of a prism is just PH. A lot of times you might even use a capital P there because it's the perimeter of the base. The surface area is basically the lateral area, or pH, plus 2b, where the b is the area of the two bases. If you'll notice in the prisms that I've drawn or the prisms you see in the book, they always have a top base and a bottom base. Those bases will be the exact same shape and have the exact same area. So we're basically, when getting the surface area, having to add the area of both bases. Let me show you how this works in problem number 2. Problem 2, we've got a triangular prism. So there's the top of it. Here's one side. Here's the back side of it that we can't see. And then there and there. So now you can see our triangular prism. We've got a right angle here. So we know it's a right angle right there. We're told that it's 3 centimeters on this side, 4 centimeters on that side, and 6 centimeters between the two bases. All right, so we've got to figure out the lateral area and surface area of it to get the overall thing. So perimeter times height is the lateral area. So the lateral area is equal to pH. Well, the perimeter is just going to be the 3 and the 4, basically the perimeter of the base. So if we've got this 3 and this 4, the problem is we don't have that part of the base, right, or that part of the triangle right there. This part that I'm going to highlight right here, we don't know, but we know it's a right triangle. So let's just use the Pythagorean theorem. 3 squared plus 4 squared equals the hypotenuse squared. So this side must be 5. Okay, so now we do have the overall perimeter. 3 plus 4 is 7. 7 plus 5 is 12. For the lateral area, which is the area of the 3 rectangles around the outside of the prism, you would take that figure and multiply by 6, and you would get 72. Now, the surface area is equal to the lateral area, or pH, which is 72, plus 2 times the base. But the base is a triangle. So I would actually put in here 2 times 1/2 base times height. That's the formula of a triangle. Okay, so now we can take our surface area, and it's equal to 72 plus 2 times 1/2 is just going to be 1. Those are going to cancel out. It's basically the base times the height of the triangle. Because it's a right triangle, that's very easy to see. If the base is 3, the height is 4, or 3 times 4. And so our surface area of this particular prism is going to be 72 plus 12, or 84 centimeters squared. Do not forget that any area calculations, including area calculations of surface area and lateral area, will be in things squared. All right, so that's a prism. That works for all different types of prisms, but keep in mind, let me go back here. This part of the formula will change based upon what shape you've got. Because we had a triangle, a triangular base, we had to use 1/2 base times height to figure out the area of those bases. If they were rectangular bases, you'd use length times width. If they are some type of a regular polygon, like a hexagon, then you'll have to use the apothem and 1/2 PA, 1/2 perimeter times the apothem, and any of those formulas that we learned in the last chapter. So just be flexible. Don't be afraid to pull out the book and look back in previous sections or in the reference section, or even online if you want, to recall what the area calculations are for various shapes. Let me finish getting this erased here. All right, now let's talk about a cylinder. The only difference between a cylinder and a prism is that the top and the bottom is going to be a circular base. So this is the part of that cannot be seen. And so it's got a very similar formula. Okay. The lateral area of a cylinder is just the area around the outside. Basically, it's a rectangular shape if you pulled it out into a net. And the lateral area is 2 pi RH. Well, how is that similar to a prism? In a prism, it's perimeter times the height. Well, what's the perimeter of a circle? 2 pi r. And so the lateral area is just 2 pi RH. Surface area has to also account for the top and bottom base, which is a circle. So it's still 2 pi RH plus 2b, but we know what the area of a circle is. So rather than write plus 2b, let's go ahead and turn it into plus 2 pi r squareds, which is our top and bottom bases. And in that respect, a cylinder is almost exactly like a prism, just using circular perimeter, circumference, and circular area, pi r squared. There is a problem that involves a cylinder on problem 4, but I don't want to really draw that one out. Let's instead do the one on problem 3, finding the surface area of a cylinder. The radius of the base of a cylinder is 4 inches. So we would just draw a radius across there and label that as 4 inches. So we've got a 4-inch radius on one base. The height is 6 inches. So the height is always the piece between the two bases. The height is 6 inches. What's the surface area? Okay. So the surface area, just got to fill it in, is equal to 2 pi my radius, which is 4, times my height, which is 6, plus 2 pi my radius of 4 squared. And so let's start simplifying this down, and it's just going to depend upon Math Excel whether they want you to estimate it or leave it in terms of pi. This one would be 24, 6 times 4 is 24, times 2 is 48 pi, plus 4 squared is 16 times 2 is 32 pi. And so we could simplify that all the way down to 80 pi. And then you just have to check and see if it asks for it in terms of pi or in an estimate rounded to a nearest tenth or hundredth or whatever it may ask for. But in this case, we'll just leave it at 80 pi. I don't think these calculations are overly difficult, but you do need to take some time to write the formulas down on maybe a separate sheet that you will use for your test. And you need to look through the book and make sure you've got the terminology down. I used it all, or at least tried to, during this little lesson. So hopefully, let's see how far we're at. We're at almost 14 minutes, so we're under the 15-minute range. This should be good. I'll attach this to the assignment, and I'll see you in our virtual meeting this week.